Let's go ahead and begin this portion of our lesson with a review of what we did in our last lesson. In the last lesson, we talked about negative and zero exponents. The first important property that we covered is that any number with a zero exponent is equal to 1. And really, it's any number or variable. Okay, so if I had 7 to 0 power, that is equal to 1. That's a 0. If I had a to 0 power, that is equal to 1. If I had 2b to the 0 power, remember that this 2 has an exponent of 1. The exponent for b is 0, so b would become 1, so this would become 2 times 1, which is 2. With a negative exponent, it switches places in a fraction. So for example, if you had 2c to the negative third power, remember to look at these individually. 2 is one term, and c to the negative third is a second. The exponent for 2 here is 1. The exponent for c is negative 3. Since c is the only one with a negative exponent, it moves to the bottom of a fraction, so you do the reciprocal. So 2 stays in the top, and c moves to the bottom where the 3 then becomes positive. So this would be our fully simplified version of our original problem. Again, just another quick problem. If I had 4x squared y to the negative fourth over z to the negative second power, any negative exponent switches places. Remember to look at these individually. 4 is one term, x squared is another, y to the negative fourth is another one, and then we have z to the negative second. Anything with a negative exponent moves. 4 has a positive exponent, it stays. X squared has a positive exponent, it stays. Y has a negative exponent, so it goes to the bottom, moves to the denominator. Z has a negative exponent, so it moves up top where the 2 becomes positive. And there's your simplified version of the original problem. Moving forward with these different exponents, negatives and zeros that we've been talking about, we're moving into scientific notation. You should have already seen this obviously in science class, but just as a refresher, any number that is in scientific notation, I guess I should write that, any number in scientific notation is written as a number times 10 to a certain power. The important part of this number here is that it must be greater than or equal to 1 or less than or equal to, less than 10. Let's go ahead and get rid of that. So we are saying that the number before the multiplication symbol can be 1 or higher, smaller than 10, but not equal to 10. Okay, you can't do that. So if we had 4.9 times 10 to the second, this is in scientific notation, we're good. However, if we had 64 times 10 to the negative 2, this is not in scientific notation because this number is not between 1 and 10. Okay, so before we move into any problems, I just wanted to show you this. You don't have to write it down, but I tend to get a lot of questions about who will use this, when will I need this. So here are some examples of the different types of people that actually use scientific notation on a daily basis in their job. Astronomers, the meteorologic department, electrical engineers. If you're a chess player, those who are really good at it are really good at math and logic, physicists and geologists. So this is a pretty common concept to use in the real world. One important thing that you need to remember is when you're changing from standard notation, which is just a number, okay, standard notation, 3, 5, 722, the standard notation. When you're changing from standard to scientific, you have a couple of options. You will either end up with a positive exponent or a negative exponent. And how you can tell is based on this original number. So let's say I wanted to take the number 348 and put it into scientific notation. Well, remember that this number must be between 1 and 10. So any whole number, the decimal point is here. So what we have here, if we wanted to put this into scientific notation, we need to create this number so that it falls in this range. So if we move our decimal point over here and then over one more time, we end up with 3.48. Okay, so we moved over twice. 3.48 is between 1 and 10. Now, because we went from a larger number to a smaller, so 348 is bigger than 3.48, that means you will use a positive exponent on the 10. Now, the exponent will match with however many times you moved over. We moved twice, which then means that this exponent would become 2. Your other option is that you have the original number smaller than the ending number. An example here would be if I were to give you 0.057. If we wanted to change that to scientific notation, remember that it must be between 1 and 10, but not equal to 10. We take this decimal point, we move it over 1, and then 2. So now, once we've moved it twice, what becomes is 5.7, so that's our number between 1 and 10, times 10, and now it's a negative exponent, and we moved it over 2 full times, so it's negative 2. So when you see a negative here, this means you're moving to the left. When you see a positive, it means you're moving to the right. So if we were to go ahead and write these numbers that are in standard notation, so this right here is standard. Okay, so if we were to take this standard notation and write it into scientific, remember the decimal point is always at the end of the number, so it goes right here. If there isn't one written in, it's at the end. We count how many times we're moving over. 1, 2, 3, 4, 5. So we get 6.78 times 10. And then if you look at the number, larger to smaller. So that means it's a positive exponent. And how many times did we move over? 1, 2, 3, 4, 5. So 5. So there it is in scientific notation. And moving on to the next one. Now we have the decimal point here. So we want to move it over till we get to a number that's between 1 and 10. 1, 2, 3, 4, 5. I guess that's coincidental that I gave both examples with 5s. Anyway, that ends up being 3.2 times 10. And now since we went from a smaller, so smaller to larger, we have a negative exponent and it was a negative 5. So our starting number here was much smaller than where we ended up, 3.2. Same with this one, this 678,000, much bigger than this one. Now if we go backwards from scientific to standard, anytime you see a positive exponent, you're going to take that decimal point and you're going to move it to the right. It means you're getting a bigger, bigger, bigger number. Okay, so one good example of that, and actually something kind of interesting with those, is the weight. Never mind, we're going to do that in a minute. Sorry, I'm getting ahead of myself. Let's say we have 2.67 times 10 to the 6th power. This tells you how many times you'll move, and the fact that it's positive tells you that you will move it to the right. So find the decimal point, move it over. Now we've only moved it twice and we're at 267. Since we've only moved it 2 times, we have 4 more times to move it, which means that we have to add on 4 zeros. So there is our number in standard notation. Now with a negative exponent, the decimal moves to the left. So if I use that same number, 2.67, only this time I made it 10 to the negative 6th, what this would indicate to you here is that you're moving to the left. So we would locate the decimal point, move over once, right here. Then from there, we still have 5 more times to move it over. 1, 2, 3, 4, 5. And then we fill in zeros in all of these spots. So we end up with 0, and then the decimal. We have 5 zeros, and then our number that we begin with. So this number is equivalent to this number in scientific notation here, standard here. So if we go ahead and look at these two, this number right here actually is the weight of an Asian elephant. Kind of interesting if I do say so myself. Positive exponent. So if you see positive exponent, means move it to the right. So you take that 5.5, you move that decimal over 1 time, and then you have 5 more times to make a total of 6. So 5, 5, and then you've got 1, 2, 3, 4, 5. So we have moved it over officially 6 times. The next example, negative exponent. Which means you move to the left. So you start with the 3.1, locate the decimal, move it over 3 times. So 1, 2, 3. So we'll have 0 point, and then we have 2 zeros, and then our 3, 1. So positive exponent to the right, negative exponent to the left. Now, if you are dividing with numbers that are in scientific notation, it's actually pretty simple. All that you really have to pay attention to is the number ahead of the decimal point. So let's say I had 3.4 times 10 to the 3rd, and I wanted to divide that by 2. All you would do really is take this 3.4 and divide it by 2, which would give you 1.7, and you just keep it as times 10 to the 3rd. Of course, you could always write it in standard notation and then divide and then flip it back to scientific notation, but you don't have to. Now with the multiplying, you only have to multiply the number before the multiplication sign. So if you see something like this, 3 times 2.55 times 10 to the 4th, The only numbers you need to multiply are right here, 3 and 2.55. You keep the times 10 to the 4th just as it is, and when you do that, you end up with 7.65 times 10 to the 4th. And again, if you wanted to, you could write it in standard and then multiply and then scientific notation, but I think it's easier to just go ahead and use your multiplication this way.